Landing gears down and locked. Main gear touchdown. Nose gear touchdown. Discovery rolls out on runway 22 at Edwards at the end of mission STS-31 after traveling 2,068,213 statute miles on this mission.
Scientists know that less than a quarter of the matter in the universe is actually visible, in the form of stars, nebulae, gas, and so on. The majority is dark matter, which cannot be seen directly. Astronomers have had compelling evidence for the cosmic web for years, thanks to galaxies clustering along it. But directly observing the dark matter web itself has been far more difficult.
In fact, the very first successful observations of a filament of the web were only made earlier this year. Now, a team of scientists have used Hubble to take this a step further, making detailed observations of a dark matter filament, measuring its length, shape, and density.
In 2004, we peered further back in time than ever before, and captured the light from the most distant galaxies in the universe. The image is called the Hubble Ultra Deep Field. It's a picture taken by the Hubble Space Telescope over a period of 11 days, and it focused its camera on the tiniest piece of sky just below the constellation of Orion. Now, it's a piece of sky that you would cover if you took your thumb, held it in front of your face, and then moved it 20 times further away. But the Hubble captured the faintest light from the most distant regions of the universe, and it took this photograph. Now, almost every point of light in that image is not a star, but a galaxy of over 100 billion stars. The most distant galaxies in that image are over 13 billion light years away. That means that the faint light from those galaxies began its journey to Earth 13 billion years ago. That's over 3 times the age of the Earth.
The oceanic waters below 200 meters contain some of the largest ecosystems on Earth. Yet they also remain the least explored. At these depths, light and oxygen eventually fade, and the water pressure becomes increasingly immense. But surprisingly, a wide range of unusual creatures can thrive here. Access to this dangerous environment is made possible through the use of remotely operated underwater vehicles, commonly used in deepwater industries such as offshore hydrocarbon extraction. And research partnerships with these oil and gas companies provide scientists with unequaled opportunities to study this deep-sea ecology. Mark Benfield and his team with the Gulf Serpent Project have been actively doing just this for the last 7 years, and within this time have produced the very first footage of an oarfish in its natural environment. This particular species is referred to as a giant oarfish, and it is the longest bony fish known to man. Estimates of its maximum total length have been reported to be up to 15 meters, but confirmed measurements have been no greater than 8.
Macro-pinna is a small, dark fish with large fins, a tiny mouth, and a remarkable pair of eyes. The two green spheres in these video shots are the lenses of its tubular eyes. Behind the eyes is a set of large scales. The eyes are enclosed within a transparent shield, sort of like the canopy of a jet fighter. In front of the eyes are two dark capsules containing the fish's olfactory organs. Typically, Macro-pinna sits quietly in the water, using its big fins for stability, while it scans the water above for food. When it spots food, it can rotate its eyes to look forward, to include its mouth in the field of view.